Hi everyone, this is Navika, cloud engineer and a Microsoft Most Valuable Professional in Azure. Welcome back to the 29th episode of Tech Chat with Navika as we discuss scalable small language models with Azure AI Foundry today. And I'm so glad to host Thomas Tomow for the second time on the podcast. Thomas is a co-founder at Xebia Germany and executive board member at Xebia Germany, dealing in operations and technology. Additionally, a Microsoft Most Valuable Professional for consecutive 8 years. With a strong background in cloud and Azure technologies and years of leadership experience, Thomas drives innovation and excellence in technology, focusing on modern solutions like Azure and AI. As a Microsoft MVP, he is dedicated to sharing his knowledge and setting new standards in the industry. Thank you so much, Thomas, for praising the podcast once again. Additionally, what makes this podcast more special is that we are going to be having real-time Indian Sign Language interpretation. And for that, we do have Stuti with us today. Thank you, Stuti, for joining in. Thomas and Stuti, over to you if you would like to add on to your introductions.
Thanks, Navika, for this short introduction. I don't know what I can really add to this because it was right to the spot. I really like to work with technologies, especially in the Microsoft stack. So therefore, I'm awarded as MVP, and especially the cloud technologies are something that I really hardly invested with my heart. And also that I got awarded for the AI section is also something that I really like because I had a long time with AI just before the hype arise. So I really like that area, that field where I can focus and concentrate in business and also projects. So that is what I really do. And I'm pretty curious about everything that is new in technology. So I'm also driving a little bit into that direction to fiddle around with new technologies and have a lot of fun with that.
Yes, thank you so much, Thomas.
Thank you.
All right. So, without any further ado, let's get started and dive into today's topic, that is scalable small language models with Azure AI Foundry. But before we actually dive deep into it, scaling SLMs efficiently requires a clear grasp of its core infrastructure and the entire structure within. And therefore, I think the best way to start this podcast would be to start with the basics, that is what are small language models and how do you think they differentiate from the LLMs, that is the large language models.
So it's a good thing to start with the basics. So LLMs, I think most of the people that I expect watching this podcast are familiar with the LLMs. So there are a bunch of families like GPT or Claude from Anthropic or you name it. So Gemini and so forth. And all those LLMs have huge capabilities. So if you use it, then you know that they answer nearly any questions about any area in your life. So that's quite a huge benefit for us. Compared to this, if you start using SLMs, then you will figure out pretty fast that they are not that capable like the LLMs. So therefore the name small language models. So they differentiate between against the LLMs and their sizes, for example, but also in what they really can do. So they are small in size, they are small in the context and the content that they can deliver. And therefore, we have to use these small language models a little bit differently to the LLMs. And this brings, on the one hand, benefits, but also on the other hand, a little bit of pitfalls, would say. And we can talk about that a little much deeper if time goes by, because I think that is pretty much related to all the other stuff that we can talk about today, especially if it comes to an ecosystem like AI Foundry.
Absolutely. Thank you for that. As we're diving in and if we talk about bootstrapping your SLM journey in Azure AI Foundry, in my opinion, it typically means picking the models that literally hit the sweet spot somewhere between the inference speed and accuracy. So going on the similar lines, are there any suggestions to get started with some specific SLMs?
It always depends. So I'm consulting. I have to answer by it depends. But dependent to your situation, you can choose from a variety of SLMs, like you can also choose from LLMs. The thing is, if you have a need for fulfilling a special task, like you want to, let's say, get a little bit more context of what you see, for example. Let's talk about a small vision language models. Then you start best with a little small language that is capable of vision capabilities. But then you are a little bit scoped to what it can see and can describe. So there's not so great variety in those models. So you can start, for example, with a small VLM, small with an O written, and this is in version 2. So you can take this and you have a great advancement if you are using this in regard to efficiency and also in the fast inferencing. So by the way, inferencing means calling an LLM or an SLM with a little bit of request and getting an output. So this is what I'm talking about. So if you want to start with vision language model that is pretty small, but is also a little bit limited to what it can describe, but is high efficient, usable, and you need really instant feedback, then you can start with a small VLM, for example. If you want to just work with text and your scope is just working about something that you want to get as text input and get a text output, and you also want to use the efficiency of that little models, then you can also start with Gemma 3 in version 4B or whatever. So we can also talk about a little bit of the Bs that you often see at such kind of models. Then you are pretty done with the text, let's say, analysis or text inferencing if you're using that kind of model. But as I said, there are varieties of that small language models that you can choose from. The question implies also, what do I have to look for if I want to start with a specific small language model? And then often the question arises, like, what is that you really need? Because all the small language models have specific limits, and you have to know them. But the limits comes also with a little bit of things that you have technically to decide. So if you take Phi is a model from Microsoft, for example, in its version 4 dot whatever, so it's always a bit better or minor version, then you have a pretty efficient model that is capable of a lot of context. So it means it knows a little bit more from the word than maybe others. It compared to other small language models, it consumes a little bit more of memory if you have it, let's say, physically loaded somewhere. Also, if it's loaded in the cloud, then you have to deal with that because it's containerizable. Than other small language models. And that makes it pretty hard to differentiate between the models, what is best usable for your scenario. So it needs a little bit of, let's say, a decision catalog where you can go through and see what is the best model for my approaches, for my goals, to choose the best one. And often, honestly, is this task a little bit of experimenting. So like trying this and comparing it against others. It's not benchmarking. So yeah, that's something that I can say from my experience.
And thanks for that. Thanks for the detailing and also explaining that what model is for what use case. So I think that was pretty detailed and beneficial as well. So great. Now that we have sort of a short list of what we can call starters, SLMs, I think choosing the right model is like only half the battle. But if we speak from the operational front, right? Like I would really like to know, when should teams or organizations use SLMs over LLMs, or like what are the use cases of scenarios of each one of these? And in your opinion, how does Azure AI Foundry feature set aligns with each of these scenarios?
Yeah, so that results often in a kind of matrix that you have to do. Like, okay, what are my requirements, and what do I have to do then if I cannot get my requirements running? So yeah, then you compare between LLMs and SLMs. As a company or as an organization, I always have to, or I can just use often those general how can I say, restrictions or yeah, um, governance policies, if to say so. Like, what is with my data? So if I stream my data into an LLM, that is maybe not in my hands, so I don't have control about that, then what to choose from? So here comes a little bit of a trick, let's say. So LLMs are often so big as an organization that I cannot control it in my instances, because having those resources is nearly impossible for a general, yeah, let's say a normal company. So then, if you also want to consider for LLM, then you have to bring trust into the vendors, let's say contracts or promises. So this means that if you have sensitive data, that you have always be careful. So in that case, it's often a better choice for small language models if you have the abilities to run them. Small language models, as I earlier said, are in size small, means that you don't need so many resources to run them. So if you are using then small language models for your own requirements, of course, sensitive data do not have to go into, let's say, an external ecosystem. Then you can use the SLMs, especially in your containerized own ecosystem. But you can also use Azure to run them there in a controlled instance, which is a good benefit for companies. So if I have to decide as an organization for the secureness and safetyness of my data, then I should choose a language model that is for me usable and controllable, which is often an SLM. So in that case, then I can do with that what I ever want to do, and with what capability I have. So I either can run them in a cloud, containerized, because of just using a fraction of the resources that an LLM would use, but I can also run them on premises with ease, let's say. So sensitive data is the one thing, but on the other hand, it's often also the case that I have to think about what is really necessary when it comes to resource consumption. We all know running LLMs means we are also burning energy as much as we can. And that is often also not a good decision to run LLMs request just because I want to get an output like, hello, how are you? And the LLM should answer with, I'm fine, thanks. So for that use cases, it's always better to choose for an SLM that is enabled to answer in a more specific way. So here comes the next benefit for an SLM. So you can train an SLM for a specific use case, which can be more efficient than an LLM, which is more for general knowledge known, while an SLM has the possibility to be really specific and therefore also efficient in answering your requests. This is one of the second ideas that I have. If it comes to what should I choose primary, like SLMs before LLMs, something like this. What else? How to say? Often it's sensitive data and just the specific training abilities of SLMs. Yeah.
Got it, absolutely. And I think just to sort of summarize what you've said, if that would be fair, is like choosing between SLMs and LLMs isn't just about size, but it's also about a strategic fit, right? Considering the use cases, latency, cost, privacy, I think all of these plays an equal amount of role in making this decision, right?
Yeah. One comes into my mind that we can say is an addition and a benefit. So if you are using SLMs before LLMs, you have the possibility to move to be more agile. So if you think about you have to restructure or you have to adopt your application that you build with an LLM, SLM, then you can always decide for moving this SLM from the one environment to another environment, which is also a good strategy if it comes to being more flexible.
Oh, then that's like a big, like one of the big, what should I say, like perspective that one should look at before making a choice. Thank you for sharing that. And thanks for sort of mapping between these use cases and Foundry capabilities as well. That sort of clarifies a decision framework for us. Now let's sort of dive into the nuts and bolts, I would say. And if you could please help us explain as to how does an Azure AI Foundry sort of streamline an end-to-end SLM workflow, maybe, just start from data ingestion to containerized deployment. So if you would like to throw some light on that.
Oh yeah, Azure AI Foundry is really, let's say, evolved ecosystem about machine learning. So machine learning at all. So just to also make it clear, we are talking about LLMs, and LLMs are also, let's say, an AI. Often people are just, let's say, mismatching AI with what usually is known as machine learning. But anyway, so AI Foundry is the base for all the people that want to do AI. Let's stick with AI. So means that you can create your own models with AI Foundry. You can let's say you can train them, you can use fine-tuning from your LLMs, but you can also create object detection models if you like, which are not LLMs. So we have on the let's say on the start, working with data, creating a model, fine-tuning a model, tuning it to a specific knowledge, for example, or a specific output. Then you can use Azure AI Foundry especially for that. It was formerly known as Machine Learning Studio. So it's not just a new thing that is just defined in AI Foundry, but now the whole ecosystem around AI is now put together, collected as a big tool set with a nice looking UI above that. So if you as a company or as a private person that want to create an AI, especially for one task, then you use this part of creating the model, fiddling with the data, and you stream your model pretty fluently in a Foundry into a catalog. So there it resides, and you can choose from. You make it also available for others, so you can collaborate with people on one model or also on the data that you feed the model with, which pretty much what you need for collaboration and getting an idea into something that you can really use. Talking about this streamlining, so in form of having a pipeline, then AI Foundry is a pretty huge environment or platform ecosystem, whatever you want to call it, to fulfill this task of collaboration on a model, on an idea, and streaming it into the model catalog. Taking it from the model catalog enables you or a team of developers, for example, to work around this model. So also the AI Foundry ecosystem enables you to work on models. Especially it makes you, or Microsoft did a good job to help you comfortably work on a model. So you can just click a button, you have an online Visual Studio Code, you can directly work with code and do inferencing into your model, which is pretty much what every dev wants, just a click and you are done. And then you can also deploy your model to somewhere. So you can use the AI Foundry ecosystem to deploy your model directly as a container to some spaces in Azure that you provided. So you can then start inferencing a container ecosystem where your model that you created with AI Foundry is, let's say, able to be publicly inferenced. So which is great. So you have pretty fluent established streamlining, pipelining process from A to B without any obstacles in the way, let's say. And that is a fluent process that you can benefit from. So therefore, I also like this ecosystem pretty much because you don't have to fiddle around with media breaks or different tool sets. So you're pretty much done. And also this is benefit for most of the companies that are really interested to have a whole, let's say, DevOps, MLOps pipeline, from creating something into putting it somewhere into public or into official release where everyone can access it, which is pretty much fine, I think.
Thanks for that. And I think thanks for explaining the end-to-end detailing. And I think this also covers the part as to what makes Azure AI Foundry sort of, stand out from all the other services in the same landscape. But if I were to take this as a separate question, if just you would like to add something to it, as someone who sort of, I'm sure, evaluated multiple stacks, what, in your opinion, makes Azure AI Foundry sort of your go-to choice in such a crowded landscape now?
Yes, as I said, so from my perspective, this ecosystem around AI and Microsoft stack is so homogenized that you can just start with an idea and you can just move your artifacts from one step to a next step, so until you get the final result. So that makes you pretty, let's say, efficient when it comes to, you have to start fast and you get your output as fast as possible, without fiddling around with stuff that you have to break from one application to another one and have to transport the artifacts like a model and so. So taking into account, for example, Hugging Face as ecosystem where you host your models, which also has a huge model catalog where you can just go through and work like you go into a supermarket, then I'm missing a little bit of the ecosystem that comes after. So mainly if you are using one of those services out there for working with models, you have just the capability to work with models and data. Then it's done, which is pretty much fine for the most people. But if I really like to work as a developer on the whole story, then I need much more than data and the model. I really need the possibility to work on the idea to collect the data, which is possible with AI Foundry. And I have to then create the model, which is possible in all the other services. But deploying the model into an ecosystem like Azure itself is something that, for example, Hugging Face is not able to do because it's missing Azure in the background or any other cloud. So which is a benefit for AI Foundry in Azure. So you can just deploy into the same ecosystem and you can stay there. And it makes it pretty much fluently done as a developer, from a developer perspective. So having this said, I also missed the part afterwards. So if just comparing to Hugging Face, because most people know that already, you cannot work with your artifacts fluently. So if you use Hugging Face, then you provide your model. It's somewhere and you can use it. You do your inferences on that. The thing is, as a developer, you work then from a different ecosystem again. Do your inferences. In Azure, you are sticking with the same things as before. You can just work on your pipelines from the DevOps perspective. You can really work from AI Foundry into your development ecosystem and keep on working on that. And then you have a big loop, like you find as a developer, your application is deployed, you get feedback, and you find, okay, you have to do something on your model. Then you go back to the data and you work on your model. Or you directly can participate and benefit from the changes as a developer. So collaboration is a thing, and I think that collaboration between data engineers, how is it called? Most days it's AI engineer working on the model itself, and the let's say standard developers like I am, can work collaboratively on one ecosystem, which reduces, for example, time for context shifts or context switches. I know that running a company means that you have to care for, let's say, switching too much. So having context switches for developers and switches for those and them. And also, for me, it's always important to bring everyone on the same page and having the same table that they're eating on. So it means having an ecosystem where they can really keep their fingers in. They just work on the ideas and being creative, not just fiddling with tools. And that is something that really eats time. And I try to avoid it as much as possible. Therefore, just to emphasize that is Azure AI Foundry for me something that is really beneficial and important.
Yeah, that was pretty educative. Thanks, Thomas. And needless to say, the answer is literally summed up as to what makes Azure AI Foundry, go to choice. Now that we are almost towards the end of the podcast, I would just like to wrap this up with one last question. Now that we have literally reached to covered most of the parts of SLMs and all the other scenarios associated to it. SLMs are pretty lightweight and efficient, which sort of makes them ideal for edge and on-prem deployments. As a last question, I just would like to ask that how does Azure supports this vision? As in, like, can local environments or on-prem IT infra benefit from the Azure AI Foundry?
That's one of my let's say most interesting fields where I am working on, because everything that happens in the cloud is still good. You have a lot of benefits, but often it misses a little bit of possibilities for us people. So if take the scenario that we had before, if we are a company and we have work with sensitive data, then we can take a small language model because of efficiency, and that's what I said before. We can host it somewhere in the cloud as a container instance, and we can use the cloud. But we have the problem then in that case, we are losing control about our data because it's just moving to the cloud. So wouldn't it be better to have this small language model running somewhere in our environment or in our instances? I think so, and that case makes it pretty interesting, because then you have also, if you think about what is a small language model, the possibilities to just download it, which is impossible with an LLM. Just a few words to the sizes. Often we are talking about a small language model if it has less than 30 billion parameters, which is really a small language models compared to a small language model. Often like if I can give you an example for GPT 3.5, no, GPT, what was it? 3.0 mini with about I thought it was about 200 to 500 billion parameters, which is pretty much in size. So it is, no, not billion, it was much more. But compared to that, it's impossible to download just a GPT model. So therefore, if you can download a small language model, you can run it in your own instances. And then you can run it pretty much and pretty fast, as like you can with your resources. Now, to answer the question, what AI Foundry can do for us is Microsoft invested in a tool set that enables the download of let's say, curated models that you can also find in the model catalog of AI Foundry. So with that possibility, you just install the Foundry CLI in your laptop, which currently is for Windows and Mac operating systems. But you can download that, and easily you can just type Foundry run and the model name, and it downloads the model from the model catalog from Azure, and you have it on your PC running, which is pretty fine. So you have everything under control. So everyone can do that. It's not just a company and it needs the resources to run an SLM. You can also, as a private person, download it simply and do your experiment on your own PC, which is a pretty interesting playground for most of the tech enthusiastic people like me. But this, in addition to AI Foundry, comes now from Microsoft to enable for that use cases and scenarios, which also can use companies that have offline data and work on offline data. So the last piece that is missing in other services is just to get the models fluently downloaded and work with them on your own PC. And this is the last edge case that was missing in the AI Foundry, which gap is now, let's say, filled.
Yeah, absolutely. That was very informative, and thank you so much for covering that part as well, Thomas. And this brings us towards the end of the podcast, and literally how 30 minutes passed by, I didn't even get to know. Always great to hear from you, Thomas, because you're such a experienced and learned professional, and it's always a privilege. Honestly, it's always a privilege to host you and even to learn from you
Thank
in
you.
this
Same
process.
way.
So thank you once again. Really, really grateful to have you. And thanks, Toti, as well. These podcast series are becoming more and more special as we are having these ISL interpretation also. And the whole idea is to make the podcast sort of, accessible to as many people as possible. And that's the whole idea behind it. And I hope that goal is achieved as well. So thanks to you, Stuti, also. Yes, and before we sort of sign off, any ending notes, Thomas, that you would like to give?
I really enjoyed this podcast. I'm so sad that it's just a fraction of time that we would need to talk about the whole landscape of small language models. Language models is pretty fast evolving topic. I think pretty much people are interested in. I will always enjoy having podcasts with you, so I can give you back the compliments and feedback again. So I really enthusiastic about the next one, maybe next year. We'll see.
For sure, for sure. Always ready.
So yeah, with that having said, I really appreciate being here. Thank you very much.
Thank you so much. And for the audience who is watching this, I would definitely say that, apart from this podcast, also, I mean, if you would like to learn more, I'll try my best to get Thomas once again from his busy schedule if we can in the next podcast. I swear, it's always an honor to have you. And also, as free resources, you guys can also refer to Microsoft Learn documentations. You have plethora of them on Azure AI Foundry over there as well. So anyone who would like to learn more about it, I would just say just go and sort of head on there. Yes, thank you so much once again.
Have a nice day.